you look at 5G and OpenRAN and the fact that the big effort to use, MEO, LEO, GEO satellites to create a global internet coverage any corner of the world, so that you can take a TikTok when you're in the middle of the Sahara Desert. I actually used that in a presentation recently, and it doesn't sound. It doesn't sound like it's practical, but in essence, that's all of these this new era of high-speed connectivity is enabling all these use cases that 3 to 5 years ago we wouldn't have thought about. And it requires, when it comes back to Samtec, when it comes back to semiconductor providers, when it comes back to EDA test and measurement, it's like, how do we enable that at the physical layer? And innovation is accelerating across the ecosystem.
Hi everyone, it's Judy Warner. Welcome back to this week's Ecosystem Podcast. Today I'm joined by Matt Burns, who is the Global Director of Technical Marketing at Samtec. We're going to talk about how we are entering a whole new era of high-speed technology. We're going to talk about trends in technology, what those drivers are towards increasing speeds, the challenge with the ecosystem that's continually expanding and growing up to support these applications. And then we're going to talk about the challenges of interconnects and what Matt and his team are doing at Samtec. He's also going to tell you what you need to be paying attention to and how to plug into a resource that'll keep you continually up to speed on what's going on in the industry. Now let's jump into our conversation with Matt Burns of Samtec. Hi, Matt. Thanks so much for joining us again. I'm glad to have you back on the podcast.
Judy, it's always a privilege to talk with you. We love being on your podcast series.
Thanks. Well, I love having you. It's always a fun talk. So I thought I'd get you back in as we sort of cruise into fall and head towards winter. A couple podcasts ago, we talked about sort of paving the road to 224 gig. And I know just from being on LinkedIn and seeing stuff that you're posting that you're definitely making headway in that regard. And so, you've been talking about online about this new era of high-speed, really high-speed technology trends, but high-speed technology overall. So what do you see going on, and what can you share with our listeners in that regard?
Yeah, that's a great way to set up our conversation, Judy. And one of the things that we're really focusing in on, the second half of 23 going into 24 is what we see as a new era of high-speed connectivity. A lot of people in the industry, interconnect, signal integrity, chipsets, EDA, test and measurement, everyone's focused on 224, and they should be. We should be as an industry, because that's obviously the next generation speed node. But it's not just 224 that's influencing high-speed connectivity, right? Some of the trends that we're seeing, obviously, PCI Express 6.0 was released last year. PCI6 has talked about PCI7. You're making that jump from 64 gigatransfers per second to 128 gigatransfers per second. They're targeting a release of 2025 for the base spec. CXL, when it comes to cache coherent memory design, is riding the PCI-SIG code. I shouldn't say coattails, but they're leveraging the infrastructure of PCI-SIG. CXL 3.0 supports or uses PCI Express 6.0. So those are obviously both great networking fabrics that are driving interconnect between the main compute engine on a system and various peripherals. Plus we're seeing increased demand for optics at speeds, right? There's a lot of question in the industry. At 224, are we going to do copper on package, the front panel, or are we going to use optics on package, NPO, CPO, like it's called? So there's a lot of interesting things. So from Samtec's perspective, we have our fingers kind of in all those areas. So we really see it not only as answering the clarion call of getting to 224, because that's the big focus. But all these little niches on the fabric side, copper versus optics, how does RF fit in there? Because obviously you have to be able to test this stuff and you're testing, 224, 56 gigabit NRZ. There's all these trends that are kind of tying together. And, obviously Samtec's, our reason for being is to route the data from point A to point B over the channel,
right.
Copper, optic in the RF world. So that's kind of where our focus is at, is how can we, how do we observe all these trends? How do we play our part in trying to help connect everything together? And then, where the market's taking us. So I think that's kind of been our big focus, the second half of the year going into 24.
So what technologies, you mentioned a few, right? A few, but like what other technologies are driving these kind of speeds?
Yeah. Well,
applications?
Yeah, sorry to interrupt you. I apologize. You and I and everybody in the industry is so excited about what seems like the endless possibility of artificial intelligence and machine learning, right? I don't know if dumbfounded is the right word, but I've been really excited at the interest that the general public has in artificial intelligence. And I think we can all agree that Chat GPT was really an inflection point where the general public finally starts to grasp the power of these giant sized AI models. And that's one application, right? For generative. I guess we should be careful how we talk about Chat GPT because it may put you and I out of business, but that's another conversation. I'm joking, of course. No one can replace you, Judy. They can replace me, but not you.
Yeah, no, that's not true. The guy, have you seen some of the weird AI video stuff now? It's exciting and a little scary, but we're weirdos, so we're always excited. We might be plunging to our death soon, but we're always running to the next shiny thing.
Yeah, we'll see. But aside from Chat GPT, there are some interesting and timely data sets and data models that AI has to answer, right? I was just at an AI industry trade show in Silicon Valley a few weeks ago, and obviously NVIDIA is the leader there, but there's this entire giant ecosystem of AI chipset providers, AMD, Intel, and a bunch of others, right? It's startups like Samba Nova, et cetera. So there's this whole ecosystem that is focused on trying to efficiently handle these large data set AI problems, whether it's natural language algorithms or something like a Chat GPT, which is a text inference, text learning, et cetera. So that whole ecosystem is, everyone talked about the hockey stick effect, and we're at the bottom of the hockey stick in terms of where AI is taking us. So that's affecting everything, right? Is AI designing AI chipsets? That's something Synopsys talked about from Synopsys and Cadence and EDA vendors. So you can't sit here and say that AI isn't going to influence high-speed connectivity, right? Or that next era of high-speed connectivity. And then when you start to look at AI implementation, AI hardware system architecture implementations, almost all of them are application specific. You can run, and here's the way I like to think about it. You or I could run Chat GPT on a single GPU on something that's personal size. But to scale that across a data center or multiple data centers so that you get real-time feedback for a gajillion users, you need 10,000 GPUs. That's a lot of space. That's a lot of data centers. Last I checked, that's a lot of connectors to connect all these GPUs together,
right?
Or cable assemblies or optics or whatever the case may be. So AI is definitely a major trend that we see. And, disaggregating.
I'm sorry to interrupt you this time, Matt. I have to say this, and I bet you when I ask you this, you'll say, yep. I've had 2 recent conversations with thought leaders in our industry, and twice. And one was in a conversation about NVIDIA. And I was asking about technology drivers, and they both mentioned this unlikely word, TikTok. I'm like,
of course.
What? But NVIDIA is selling a huge number of chips because the processing speed it takes for this gigantic load of streaming video. Exactly. And I was like, boy, I didn't see that one coming.
Yeah. Or, Netflix. Another application is Netflix, right? You watch one movie, whatever your tastes are, and all of a sudden you've got 10 recommendations, right? So that those practical examples illustrate how AI can perform such a powerful function in our day-to-day life. But going back to high-speed connectivity, to enable those types of functionalities, it takes a ton of compute engines, it takes a ton of servers, it takes a ton of interconnect, it takes a ton of throughput. So that's where you start to get into scalability, flexibility. Obviously, 224 comes into that when it comes to next generation channel data rates. But you start to get into another trend that we're starting to see, and this is not starting, but continuing to grow. Disaggregated computing, homogeneity. I can never say that word.
That's a tricky one.
And it is in computing, right? It's not just using. It's not just how do I figure out how to use a server to become more efficient. It's how do I re-architect the compute system to be fine-tuned towards the end application. So, there's all these trends that are driving connectivity needs, and that's in addition to just general data center growth and general throughput growth as the internet expands around the globe. This is something else that popped into my head in terms of applications. You look at 5G and OpenRAN and the fact that the big effort to use MEO, LEO, GEO satellites to create a global internet coverage any corner of the world, so that you can take a TikTok when you're in the middle of the Sahara Desert. I actually used that in a presentation recently, and it doesn't sound. It doesn't sound like it's practical, but in essence, that's all of these this new era of high-speed connectivity is enabling all these use cases that 3 to 5 years ago we wouldn't have thought about. And it requires, when it comes back to Samtec, when it comes back to semiconductor providers, when it comes back to EDA test and measurement, it's like, how do we enable that at the physical layer? And innovation is accelerating across the ecosystem, and everyone's trying to keep up. Everyone's trying to innovate their competitors. So I think, talking about trends, that's kind of where we're at right now, Judy. At least that's what I see.
Well, I'm out here just sort of taking the pulse, right? And I feel it. And one of the just incredible things I was just talking to Steve Sandler and Heidi Barnes at Keysight about was that Steve is unleashing a refrigerated probe for testing at package speed at like 2,000 volts. I'm like, what? Testing at package speed. So again, I'm sure, and then this just ripples out, right? Right. And so I feel all the disconnected pieces. So you're helping me and probably our audience put all those pieces together.
Well,
so,
I'm sorry, go ahead. I apologize.
No, you go.
Oh, one of the things I was thinking too is that, when it comes to scaling the AI infrastructure, we're looking at next generation AI chipsets that have TDPs of 1.2, 1.5 kilowatts on a single chip. That's a lot of power, right? That's also a lot of heat. So not only do you have to get the data in at 224, but how do you get the power in, and then how do you get the heat out, and then multiply that by 10,000. So, there's a ton of, like you said, I apologize. There's a ton of trends kind of coming to an inflection point that if we don't solve it as an ecosystem, we're not going to move forward.
Well, so that's a great jumping off place. So we talked, I don't know, it's been less than a year, but more than 6 months maybe, that we talked about that as we move towards something like 224, that the ecosystem has to grow up around it, which is also a theme that I'm seeing sort of across the industry. And it's all of this, right? Just different aspects of this story. So since the last time we talked, maybe 6 or more months ago, where's the ecosystem today growing up around these speeds that maybe you're noticing at Samtec and some of the work you're doing there?
It goes back to something Samtec's always messaged, Judy. Integration leads to innovation. That's sort of an internal tagline, because we like to take, we have a lot of groups of technologists, optical, thermal, interconnect, electrical, whatever. How do we get the right people working together on the right solution at the right time, right? And that's not a concept that only Samtec promotes, but for some of these solutions and some of these challenges that the industry is facing at 224, you can have let's go back to the AI chipset example for just a second. You can have the best team of signal integrity engineers, electrical engineers, and whatever to get all that data in and out of that chip, right? Design the right chiplets, design the right substrates, design the right package, how you attach it to the PCB, optimize the BOR, and that's all in Samtec's wheelhouse, right? Or most of it's in Samtec's wheelhouse. But what do you do with that power? What do you do with kilowatts and megawatts of power within a single rack? Thermal specialists, power integrity specialists. That's not just one company. It's not just one company. So it's really, how can the ecosystem partners work together to almost come up with an application specific solution, if that makes sense. A good example, right, for a lot of our solutions, whether it's our Firefly optical transceivers or some of the next gen interconnect where we're applying copper on package or copper near package, I should say. We're creating a generic, a flexible type of generic heatsink with a flat top on it, right?
Oh,
and
that's
what
interesting.
And what that allows for is someone applying a cold plate that can be used either liquid cooled or just passive, or depending upon the application, maybe they put a pin fin style solution on it that allows for just convection cooling. Again, it all depends on the specifications, the parameters of the system, and then obviously for some of these higher power solutions, is it immersion, which poses its own challenges unto itself. So that's really kind of where we're focusing in on. The reason I bring that up, you're talking about next generation solutions. One of the platforms that we've started to engage some of our tier one customers with is what we're calling SciFly HD. We came out with our SciFly solution, which was designed as an ASIC adjacent interconnect that was very low profile, that could fit next to an ASIC, and then the heatsink could extend over that. We've altered that approach so that instead of having a right angle launch, we have a vertical launch, and that allows us to get the density that's needed to support the 1024 differential pairs coming out of the next generation Ethernet switching ICs that we see on the industry from Broadcom and some of the other Avago, and some of the other solution providers there as well. So we can handle the SI, but we're having to work with partners in terms of how do we package that on a substrate, how do we package that on a package,
right?
How do we get the heat out? So we're working with thermal providers, we're working with power providers. So that SciFly HD solution is one of the first solutions that we're starting to introduce in the market. We're gonna have a soft launch of it at some trade shows, ECOC later in the fall here in North America and in Europe. So to me, that illustrates the need for an ecosystem, not only from the SI standpoint, but power, thermal, et cetera, et cetera.
So what is the ECOC, Matt?
I knew someone was going to ask me that. It's ECOC is the European equivalent of OFC here in the U.S. So it's a
like
European,
an optical.
it's a European focused optics show.
Okay.
And the event's coming up here the first week of October in Glasgow, Scotland. So it's an event that's timed nicely every 6 months between OFC is typically March in San Diego, and then ECOC is usually the October timeframe in Europe. It travels around Europe, but very similar audiences. It's focused on optical networking, but the industry's evolved beyond that because it's copper optics RF test. So it's a show that we haven't attended for a while, but we're going back to the event this year, and we're really excited about it because I think it's to give us an opportunity not only to engage with emerging ecosystem partners and customers in the European market or the EMEA market, but also just to collaborate more with semiconductor companies, EDA companies, test and measurement companies, and the like on the system level solutions where the partnerships with the ecosystems needed.
So if I'm hearing you correctly, what's easiest for you to do is actually make something real, put the ecosystem together to solve this real problem, and then sort of extrapolate out from that and continue to scale. Did I get it right?
That's it in a nutshell. You and I are talking on a podcast, so it's kind of hard to encapsulate all the details in a few minutes.
And I'm not asking you to, but that's what I heard. And correct me if I'm wrong, please.
No, that's it in a nutshell, Judy. And to me, it's because the challenges that Samtec's trying to solve as well as the high-speed connectivity ecosystem is trying to solve, those partnerships and those technology joint ventures and however companies encapsulate it, those are just necessary because it's almost impossible for one company to do it. Or, if you're an OEM that's designing these next generation systems, okay, I can work with company X on the front panel, I can work with company Y on the back plane, I can work with company Z on package or ASIC adjacent. I can work with the company A when it comes to optics, et cetera, et cetera. So to me, it's a really interesting time, and we see just a ton of innovation that's going on, and I think we're with Samtec's commitment to service, we have the sudden service model that you're so familiar with, and your listeners are so familiar with. I think that gives us a heads up because not only do we have the technology solutions, but we're going to do everything we can to work with our partners and our customers to find the right solution for the unique application in this new era of high-speed connectivity.
Well, it's just such a unique model, and without being a cuckoo Samtec cheerleader, I do think because you take so much information from bottom up, but it's not really bottom up. You're getting frontline information from industry, and feeding it up, and then the way that you're structured internally, because you're a privately held company, that can be sort of aggregated across, because you don't have business units and little silos. So whatever. I'm a fan. I should get some Samtec pom-poms. Send me some orange pom-poms.
How about if we send you some tigers, right? Everybody loves our stuffed tigers. We go to the
Right,
trade
I
shows
know.
all the time, and people
I
are
got tigers, but then I
Okay.
gave them away to other people I
No
gave my
problem.
pom-poms away. Anyway.
We'll have to replace those for you, Judy, so you can be our
Okay.
cheerleader on the West Coast. We appreciate
All
that,
right.
by the way.
Okay. So, say you're an engineer working for a fairly large OEM and you're head down solving problems, or you're an SI engineer on a big engine. What, in your mind, this is kind of a big question. What should they be paying attention to? And maybe onboarding, learning resources, of course, through Samtec, but just other places across the industry. What should they be learning? What should they be paying attention to?
And that's a great question, and I think that ties into some of the topics we talked about earlier, right? 224. Even when you talk to people like Steve Sandler or Istvan Novak or Scott McMurrow and some of the other leaders with Nathan Tracy at TE, some of the other folks that we have in the industry, they know signal integrity like the back of their hand. They really do. I mean, I listen to Scott or Istvan or some of the folks we have just talk, and I learn stuff just by, they've forgotten more than we'll ever learn, right? In essence.
For sure.
And that's not an exaggeration. You know those folks, you work with them on a consistent basis, Judy. So with engineers at OEMs, they're so focused on getting the job done. They've got so much demand on their time, but they have to keep their skill sets fresh. So,
Yes.
so Samtec we've always tried to work to do our part to educate the industry on the nuances of signal integrity, but we've really tried to focus on that over the last year or two, because of the need for increased collaboration, increased awareness around the challenges at 224. So some of the things we've been working on over the last 6 to 12 months, like we've mentioned some of these things to you, but just to reiterate for your listeners, something that's been really successful, and we really started this during the pandemic, is our Geek Speak webinar series.
Mm-hmm.
Obviously, when the pandemic started, March, April, a bunch of people were like, I need help, but I don't know what to do. And it was the perfect time for engineers to kind of refresh their training and sharpen their skills. And it, we built this immediate audience because of the unique opportunity that we've had. And now, we've been delivering Geek Speaks monthly for the last 3+ years. And we have a loyal group of audience that we've been able to cultivate and curate. They send in suggestions in terms of, hey, I need something on this topic, I need something on that topic. It's been good for Samtec too, because obviously we've got our core SI luminaries, like we mentioned with Istvan and Gus and Scott and Rich Mallets and others. But we're starting to pass that knowledge on to, if you will, the next generation of SI engineering talent within the company. So not only have our luminaries been presenting but our next generation of SI engineers have also been presenting, and what they've gone through this training process, learning from the best of the best, and they're passing on what they've learned to the industry, and we've really developed a really good following there. So now we've also gotten some feedback and some recommendations like, hey Samtec, we love your Geek Speak webinars, but I don't have time to sit there for 45 to 60 minutes and learn the intricacies of VIA design at 224. I need to refresh my understanding of some basics on SI. So two things that we've done there, Judy, and these are all available on our website, which we'll share at the end of the discussion. We refreshed, updated, and expanded our signal integrity handbook. And what that was based on is that we have a team of what we call frontline signal integrity engineers that when someone contacts us via email, this is a compendium of the most common questions that we get from our partners and from our engineering customers across the globe. What is insertion loss? What is return loss? What is crosstalk? How do those SI parameters affect my design, et cetera, et cetera. So we've taken all that information, a lot of it's up here in our engineers, and we've tried to put it down on paper in an organized and logical way. And we released this up. We released the updated signal integrity handbook at DesignCon 23, and the interest in it has been higher than we expected. So we're really excited about that. We have printed versions up that we there's no charge to it. We give it out in hard copy at our trade shows. It's also available for download on our website. So that's one thing. The second is that engineers love to watch videos, right? Especially short videos. So to complement the webinars and to complement the handbook, this year we launched in, I think it was June or July, what we call our Geek Speak video series. And these are 2-minute videos with answers from about 8 to 10 of our SI thought leaders answering those basic questions. What is insertion loss? What is return loss? Why does impedance matter? And there's a whole bevy of topics. We've released about 10 to 15 videos so far. We're releasing about one a week, and we plan to just continue to release one a week for the foreseeable future until we run out of topics, which who knows when that'll be. So those are kind of three big things. And obviously, Judy, participating in podcasts like this with you, we're always putting on webinars with our partners or by ourselves. And as you know, there's never an end to the need for our engineering community to continue to keep their skill set sharp. And we're trying to do the best we can through Geek Speak webinar series, Geek Speak video series, our SI handbook, and our new landing page at samtec.com/SIG, Signal Integrity Group. That's where you can find links to all these tools that are helping to educate the market, helping to educate the next generation of engineers.
I of course agree with you. And the only thing I think I'd add to that, and I know you will totally agree with me 100%, is get out to those trade shows when you can.
Yeah.
I know DesignCon is right after the first of the year. Are there any other shows Samtec's going to be at besides the ECOC and DesignCon coming up, Matt?
Yeah, so great question. It's a nice segue. We're taking this message, if you will, of the new era of high-speed connectivity on the road, no pun intended. So coming up in October, sorry, I'm not good with one-liners. Coming up in October, we have the ECOC show. It's the first week of October, which is in Glasgow. So we're having a soft launch of our SciFly HD product, which I mentioned. We've been showing that to some key customers already under NDA. We're at ECOC. We're also getting ready to launch a next generation optical transceiver. So we'll be publicizing some information on that here in the next couple of weeks. After ECOC, obviously a ton of folks in the industry are going to be at OCP in San Jose, the Open Compute Project, focused on open source data center. So the not only are the presentations around OCP thought-provoking and market-leading, but the list of attendees and sponsors is always quite impressive. It always fills up McInerney's Convention Center there in San Jose. So it's always a cool event to go to. Supercomputing is really making a strong comeback, right? We'll be attending that event in Denver the week before the U.S. Thanksgiving here. a lot of, just because of the pandemic, supercomputing may have suffered a little bit more than other events, but it's really made a comeback over the last year or two. So the whole ecosystem of those that use high performance computers, government, academia, industry, and the ecosystem of components and subcomponent providers just reinvigorated. So we'll be there in November in Denver, and then obviously everyone is starting to talk about DesignCon 2024. So that always seems to be the big event in our industry, Judy.
Yep.
I know you and I always I know you and I and our colleagues and friends always see each other, and we always look forward to it as well.
Yeah, I loved when I've stolen a couple things from you, Matt Burns. One is I now call DesignCon the Super Bowl of electronics. So I love that. And the other thing, sort of recap our conversation, is you said something to me and it really struck me, is you started to say, forever we've talked about, getting out of your disciplinary or your silos, right? And you made a good point to say the speeds are too fast now. You can't. And if you do, it's to your own peril. And so those are two things that you've taught me and that I've quoted you many times on, so much since then when I did my pre-show last year, I called it a tailgate party. So thanks for that little nugget.
No problem. We're glad to. I actually, I have to give credit to Samtec, one of my Samtec buddies, John Riley, who I know you know. He's actually the one internal that came up with calling DesignCon the Super Bowl of electronics. So I don't want to take his thunder.
Okay, I don't know John, so
okay. Well, we'll have to make sure you meet him at DesignCon.
Okay, I will give John creds on it, but I heard it from you. So
all right, sure.
Well, Matt, thanks so much for taking time out of your busy schedule to come update us on everything you're working on. It's overwhelming, as you said. It's exciting. And there's just so much going on. So appreciate you coming and giving our audience a sneak peek of behind the scenes and all the stuff that Samtec's working on and really was trending across the industry.
No problem, Judy. We're glad to be here. It's always fun and a privilege to talk with you and talk with your listeners. So thanks for the opportunity again.
My pleasure. For our listeners, thanks so much for joining us today. Matt mentioned the Signal Integrity Handbook, which is not only on the Samtec website, and I'll share those links with you for Geek Speak and all the things that Matt mentioned, but I also have it available on the Ecosystem website for download in digital form. So pick one of those places, go download it, because everyone I've talked to absolutely loves that thing. And then the Signal Integrity 101 videos they've created and these shorts are really great. And it's, really fast, digestible little wisdom, nuggets of wisdom. So make sure you go check out the show notes and grab all those goodies. Thanks for joining us today, and we will see you next week. Until then, remember to always stay connected to the ecosystem.